Nuclear energy and resources. By the end of this, you should be able to describe how nuclear energy is used to generate electricity and discuss the advantages and disadvantages of using nuclear fuels to generate electricity. Nuclear reactors use fission to generate electricity. Electricity generation from a nuclear reactor energy uses the same basic process as electricity generation from fossil fuels. Steam turns a turbine that turns a generator that generates electricity. And the difference is that the nuclear power plant uses this radioactive isotope, uranium-235, and that's its fuel source. I presented this concept of isotopes before and radioactive decay and half-life. So radioactive decay occurs when a parent radioactive isotope emits an alpha or beta particle or even gamma ray. And we're going to talk about this and introduce one more concept before being able to fully understand and describe the nuclear power plant. This naturally occurring isotope, uranium-235, as well as other radioactive isotopes, undergo a process that we call fission. So fission is a nuclear reaction that happens when a neutron strikes a relatively large atomic nucleus, and then it splits into two or more parts. This process releases additional neutrons and energy in the form of heat. So, additional neutrons can in turn promote this additional fission reaction, which leads to a chain reaction of nuclear fission, and that can give off immense amounts of heat and energy. And so a nuclear power plant that heats energy is used to produce steam. And just as thermal power plants as well, it'll produce steam, which turns the turbines, which makes the energy. So 1 gram of this uranium-235 contains 2 million to 3 million times the amount of energy as 1 gram of coal. So uranium-235 is one of the most easily fissionable, that's a word, isotopes, which makes it ideal for using it in a nuclear reactor. A neutron colliding with uranium-235 splits the uranium atom into smaller atoms like barium and krypton typically, and then it produces these 3 neutrons. And so the reaction is as follows. All right, so uranium-235 plus 1, that's a neutron, neutral charge, and the reaction, it'll create barium-142, krypton, which atomic mass is 91, and then 3 more neutrons. So there's many other radioactive daughter products, they're called, that are released during this process. A properly designed nuclear reactor will harness the kinetic energy from those 3 neutrons in motion, and it'll produce this self-sustaining chain reaction of nuclear fission, where they collide into another atom of uranium. And so the byproducts of the nuclear reactor include radioactive waste that remains, hazardous for many half-lives, hundreds and thousands of years longer. So the containment structure of a nuclear reactor, contained within those cylinder tubes, are fuel rods, and they're part of the steam generator. And the control rod is this cylindrical device that's inserted in between these fuel rods in a nuclear reactor, and it absorbs this excess neutrons that are produced, and it basically attempts to slow or even stop at some point the fission reaction that has taken place. There are some advantages and disadvantages of nuclear power. Nuclear power plants, they do not produce air pollution during their operation. So the proponents of nuclear energy consider it a clean energy source. But in countries with limited fossil fuel resources, nuclear energy is one way to achieve this independence, from imported oil from other countries. And nuclear energy generates 70% of the electricity from France. It's widely used also in Lithuania, Germany, Spain, and United Kingdom, Japan, China, South Korea, to name a few. These are all countries that prefer their independence on oil being shipped in and imported, so they've chosen nuclear power. We've seen that 20% of the electricity generated in the United States comes from nuclear energy. Early proponents of nuclear energy in like the 50s and 60s claimed that it would be too cheap, too cheap to meter. which basically meant that it would be so expensive that there would be no point in trying to figure out how much each consumer is using. But construction of these new nuclear power plants became more and more expensive in the United States, in part because of public protests and all these legal battles and legal fees and other delays that caused the price of construction to increase. And public protest arose because the concerns of the nuclear accidents that would release this radioactivity material into the surrounding air and water, and other concerns included really uncertainty about the appropriate location for this radioactive waste and its disposal, and so fear that the radioactive waste would fall into the hands of individuals seeking to make nuclear weapons. But by the 1980s, it had become pretty expensive for monetarily and politically to attempt to construct a nuclear power plant. So there are currently 104 nuclear power plants in the United States, and that same number has remained for 2 decades. However, a relatively low CO2 emission association with nuclear energy has caused this interest in construction of additional power plants. And so there are certainly CO2 emissions related to mining, processing, transporting nuclear fuel, as well as the actual construction process of a nuclear power plant. But these emissions are perhaps 10% or less of the related generating of the relatedness and equivalent to the electricity from coal. So, two major issues of environmental concern remain the possibility of accidents and the disposal of radioactive waste. We also have to consider that nuclear fusion and summarize the advantages and disadvantages of nuclear power relative to its energy source.